Hello everyone. We'll get going here in just a second. After I pause all the streams that decide to come back to me. All right, YouTube looks like it's going. Hello, hello. Don't forget to update the Twitch title. It should be updated. It should be. Did it not get updated? Yep. It's going. Hello, Unexpected Maker and Mark. It says Twitch should be updated. I actually do have a checklist. Hi, J Guitar. Perfect, thank you. Let's close Spotify. Oh, I'm in the wrong Discord channel off screen. Hi, Juan Carlos. Hi, Mark. Hi, Gambler. Hi, Bruce. Hi, Brent. Vin was sleeping in the window just until she got a sixth sense about it and decided that she was gonna peace out. Hi, Alvaro. Hi, Microdev. You're up really late. Thank you for hanging out. Unfortunately, we're not going to get to the sleep stuff right away, I don't think. Hi, David G. If folks want to join the Discord, you can go to adafru.it/discord to check that out. Bruce says, pro tip, never starts soldering something at 1 a.m. That's good policy. Yeah, I have a board design I need to finish, but it's a holiday present, so I don't want to show it off until after the holidays. I just, for those of you who are like, why isn't he starting? I tend to get started a little early and then go into things right after the time. So it gives everybody a chance to get clicked in and set up. Get to watch the cat sleep. He was totally snoring like an hour ago, and I tried to get a video of it, but I think me getting off my chair to get closer to him caused him to like adjust so he wasn't snoring anymore. I missed an opportunity. All right. So let me pull up my... So I put the note stock in the Discord, so if you want to follow along with what we're doing, you can check out there. Hi, Pavre6. Sleeping cat is very peaceful. Yeah, he likes to sleep during the day while we're here. I gave him some pets earlier. I got a message from Phil last week about like, oh, I love your cat cam. So great. That's awesome. Okay, let's get going. I'll switch off the cat cam. It'll be in the corner. Hello everyone, my name is Scott and I work for Adafruit on CircuitPython. CircuitPython is... Oh, well, let me pause this. It's weird. CircuitPython is an easy-to-use version of Python designed for microcontrollers, which are little tiny computers that are very inexpensive. Nice! Update from Phil, who's in the YouTube chat, says we added live to the top nav on adafruit.com, so when folks click it, it comes here if there's a live show. Alvaro says, I love the image Noe and Pedro made for the show. Anywho, good cats again, see you laters. Yeah, there's actually an internal meeting during this, so they can't always make it. Okay, so CircuitPython, very easy to use programming for really inexpensive computers. Like you get a whole computer for like 20 bucks, although it's not going to be the typical computer you think of a mouse and keyboard and display. Yeah, Phil says watch later. Awesome. Thanks, Phil. So Adafruit pays me to stream and work on CircuitPython. So you should definitely support them by going to adafruit.com. You can go there, purchase all sorts of goodies. I just got a package today, which is really exciting. I got the Matrix Portal, and I also got a Feather S2 and some other stuff. So that's exciting. Let me look at my list. So yeah, adafruit.com. Mark says the live button works. Had to try pressing it. Awesome. Okay, so this is a deep dive where I spend about 2 hours talking all things CircuitPython related stuff. If you have questions, please pop them in any of the chats. I think I've got most of them monitored by me. And I'm happy to go on tangents and things like that. It's kind of like, if you've watched the CircuitPython Weekly, which happens on Mondays, we have a section called In the Weeds. And that is like kind of the way this is too, of like, if we have stuff to talk about, we can talk about it. And it's generally led us down some really good paths. So yeah, if you've got questions, feel free to ask them. Otherwise, I have a plan that I'll go into in just a bit about kind of the things I thought I would talk about. This is the normal time, 2 p.m. Pacific on Fridays. Occasionally, if I'm doing something on Friday, I'll shift it to Thursdays at 2 p.m. But I think both this time and next week, I think, is also going to be on Friday. So no changes there. As I said earlier, if you want to join the chat that doesn't disappear when we're done, you can go to Discord by going to adafru.it/Discord. We'd love to see you there. We chat all the time. CircuitPython development chats happen there in particular. So if you like lurking and seeing what's going on, that's a great place to do it. The only other housekeeping I have on my list, I now have a notes list of stuff I want to do, is that the cat here, that's Spook, he's down to my left in the window. He is epileptic, which means he does have seizures from time to time. It has happened on the stream before. Basically what I'll do is I'll mute. Usually the camera's not up, so you won't watch it. I'll put the desktop up if that's the case. I'll mute, and I'll just take my headphones off and watch him to make sure he's okay. He's always been okay so far. But I just want to make sure he doesn't get hung up on anything. So that could happen. He's actually been doing pretty well. I think I mentioned he had switched meds a number of weeks ago, and he's been pretty good. He's been playing more and acting more cat-like, so it's been overall a net positive so far. So, yep, and the cat's name is Spook, for those of you who don't know. And with that, let's recap the plan. And I'll put a time code here as well. So the plan is, odds and ends, I want to do some release candidate 0 stuff, which is the latest version of CircuitPython that we're releasing today. I'll go over more of that in just a bit. And in fact, I think we actually need to finish it. I have a couple, 2 more tasks I got to do before I consider it fully released. So I figured we would just do that. And then I want to talk about sleepio and some API stuff, building on the work that Microdev has done, and trying to collaborate with them on getting everything going. So that's kind of the high level. So release candidate sorts of stuff, going over some things that I fixed, and then we'll talk about sleepio with the remaining time. If you have questions, as always, please feel free to just drop them in the chats. And if you're somebody, at least a few folks are in the notes docs, which is awesome. So please also remind me in the chats if I'm not looking at the notes doc and we need a time code, just remind me and I'll snag it here. And with that, let's talk about the release candidate. Okay, so I don't know how much I talked about this last week, but we're getting to the point where the stable release of CircuitPython is kind of old. And with the change of GitHub, it's actually kind of harder to find the other release. So you can see here, desktop. You can see here on the right-hand side, this is just CircuitPython. The release is here, the latest release, because it only shows the stable release is 5.3.1, and it was released on July 13th. So it's been, I don't know, 3 months since we've had a stable release. And what happens is that as we drift kind of further and further away from a stable release, we end up having to tell more and more people like, hey, check out the beta and see if the issue that you're having has been fixed there. It's like not like 6.0 in particular, we didn't change a whole lot. We didn't get a lot of kind of instability into everything. We had changed our approach a bit as well. Between like 2 and 3, we're like very specific about ports being stable. And with 5 and 6, I kind of wanted to reframe the way that we organize our releases so that a stable release is not tied to the stability of like a new port. And the reason that is that we already have stable ports, and we want to keep the people that are using that on the latest stable code for like an Atmel SAMD. So what I'm expecting to happen is that with 6.0, like 6.0 will be kind of beta for like the ESP32S2. And I'll show you here, like here's the release notes for release candidate 0. And we now have this port status section, which is like, here are the like families that we expect to be stable. Here are the families that we expect are like less stable. And like by detaching like the version number and the stability associated with that, it gives us more freedom to release more often. Because we don't need new ports to be like fully stable. It's more, you can think of it as like, it's more of a characterization of the stability of like the APIs, right? So the only reason that we are actually doing 6.0 instead of like a 5.4 is that we actually had a few cases where we wanted to change the API, not just to like add on to them. So in particular, if we look down in the release notes here, breaking changes since 5x. So these are the things that like going from 5 to 6, which like in a major version number are the things that you should pay attention to, is like the I2C slave module is now called the I2C peripheral. And the class has changed as well. We removed a stop keyword argument from the bus IO write to. We changed the default speed of I2C to be more compatible by default. So it's now 100 kilohertz, not 400. And then the last thing we did is we deleted the connection error from BLEIO because it was getting confused with the native one. So now we just use the native one. So these are the 4 changes that actually kind of dictate the different number. Alvaro says the CircuitPython Spanish translation is back to 100%. Yeah, hopefully you may not have hit that before I tagged it, but so the way, oh, hold on, I've got to order something. I have a product that we're going to be, I think I need to get developed. I'm not going to show you quite yet. I got to order it first because I don't want you to snag it before me. And I also don't want to show you how to make a free order. But there's only a few in stock. Sorry, I had a feeling this would come up during the stream. I'll show you the product after I order it. And you can, if you look on the website, you can tell what it is. Okay. Perfect. Now I'm getting all my email notifications. Yeah, so I guess I should say sometimes sometimes when new products happen, I get notified from Lemore that says, hey, you should pick this up, and it's going to go in the store today. And so I subscribe to like the back in stock notification. So the thing that I was just picking up is I just completed my order. Is this new grayscale e-paper display. You can see I just Just purchased it. There's 6 in stock. If you can wait on this, I think Melissa's got to pick it up as well. So don't just snag it immediately. In fact, I think maybe I was supposed to pick 2, but that's okay. Anyway, this is a cool e-ink display that we're just getting in the store. And it's actually just like a black and white, but it has the ability to do grayscale, which is going to be really neat. So yeah, I just picked one of those up. And it's a feather wing. I might need to change the way my Sala adapter works so I can stick it on here. And use some Wi-Fi stuff with it. Anyway, that's a distraction. Yeah, Mark asks, that is the one that you can refresh just a section to, right? Yeah, so I think this is the one that you've seen in the videos that Lamore's been posting. I don't think we'll add partial updating to CircuitPython. Lamore said that it does leave some ghosting. We'll certainly support the grayscale. I'll have to play around with it a little bit, but I'm not sure that it's that valuable, and it might be a lot of work to get working. So we'll take a look at it, but that's why I snagged it, so I can have it and play around with it. But yeah, I like e-ink a lot. I did a lot of the original work to get the e-ink support in CircuitPython as well. So yeah, that's available. Okay, that was a distraction, but I guess I could put that in the notes if somebody hasn't already. Unexpected Maker says, I know you have a busy schedule today, but if you have a few minutes, can you give a rundown on how the UF2 bootloader is supposed to work on the ESP32S2? Yeah, I can totally do that. Yeah, let's just do that right now. And maybe I can put like a end time? I have to put like multiple time codes here. I don't know how that'll work, but okay. So UF2, you know, I don't have the overhead working. 32S2. I can fix up these notes later too. So if you give me more details on how you want to work, I can explain like under the hood how it works. So if you go to UF2 ESP32S, so I know I have no APA support for the FeatherS2 yet to see which mode it's in, but I can't get it into any stage that the GitHub description says it should be in. Okay. Where's my... Do I have it on any of my Salas? Let me plug it in and see. I could just hold it up to the camera, or I could try to get the overhead working. Yeah, okay. So let me switch to here. So I have a Sala here with my featherwing on it. And I'll switch to product mode so it doesn't try to keep me in focus forever. So what I'll do is, this is my USB cable with the switch. And so the way that it works is that because there's two USBs, it can be quite confusing. So I'm going to plug it into the native USB, and let's watch what the NeoPixel does. Oh, and it's really hard to see, isn't it? Can you tell it's green? You know what? I did just get LED plastic. Let me see if that helps. This LED acrylic stuff. Too bad we can't subscribe to out-of-stock notifications till it's really out of stock. I mean, you can pick it up. It started purple, then went green. Okay, thank you. So the purple bit is when, oh, and it's got the purple bit is when the the bootloader, the stage 2 bootloader, sorry, this is the LED acrylic, and apparently it comes with the stuff on it. Yeah, so I can explain that too, David, how to get the UF2 bootloader on it if you want to try it. I want to just see if this makes the... If I just use a corner of this, it's probably going to be too hard to keep up. Can never get this stuff off. Can you see what I'm doing? I'm trying to get the other side. Interesting. It's like super smoky. One side is shiny and one side is smoky. I don't know if you can see that. So I just taken a corner off, and here you can see it like reflects the computer monitor pretty well, but if I switch it over, it doesn't. It's like one side is matte and one side is shiny. Which this is the first time I've gotten this plastic, which is why I'm like kind of interested. So if I just do this, oh yeah, look at that. So the problem is that the buttons are right next to it. So if I just hit, which button is which? So this one is reset. So you could see it goes purple and yellow and then green. Do we see that? I'll do it again. So it goes purple, yellow, and then green. So the purple is when the second stage bootloader is waiting for another reset. The yellow is when CircuitPython is waiting for a reset to go into safe mode. And then the green is when the code.py is actually running. So let's see if this works. If I just hit reset and then reset again, it didn't work. I don't know if the double tap works on this. So it's not working. But now if I do, so the other button here is boot, I think. I can't see it. So if I hit reset and then boot, now I get a red light. And the red light, that's the UF2 portion of the bootloader. And the reason it's red is because my cable is currently set to data or to charge only. So now I'm going to click my cable and it's now yellow. But the LED is still red. I don't know what version of the bootloader I have on here. It is plugged in. So let's just try it one more time. So now it's green and it popped up. I don't know why it didn't work. ASM 2750 says second stage bootloader, is this running Linux? No, it's not. It's running, it's the ESP IDF stuff. So if I switch to my desktop now and I pull up my, I think this is okay. There's nothing in here. So this is my file manager. We could see that we now have Salo1R boot. And on that boot drive, we get this current UF2, which is actually a way to copy the flash file system contents off it. We have a index HTML, which I don't actually know what it is. It's just it bounces me to the board page. And then this text file can tell me like what version of the bootloader it is. Pavre 6 is ESP IDF stuff actually an OS? That's a good question. They build the IDF around free RTOS, which like in the real-time like operating system sense is an OS, but it may not be like the type of OS you're thinking of with like Windows and things like that. Sorry, I forgot to turn on the room light. So that's proof that it does kind of work, and you know the RGB LED certainly helps to understand where it is. Max Payne Life says, what are we making? Right now we're talking about the UF2 bootloader on the ESP32S2. And so the way that this works right now is that there is a stage 1 bootloader provided by Espressif that is burned into ROM. And then there is a stage 2 bootloader that you actually load, like if you loaded CircuitPython, you probably loaded the stage 2 bootloader as well. And that's the point where we actually decide like what image to run. So if we look at this like partition layout CSV, this kind of gives you, let me make it bigger. Kind of demonstrates like, imagine this is the flash layout, and like, so where you start is you start with bootloader.bin. That's the stage 2 bootloader that you can change. Then the partition table gets read, and then it discovers that there's three kind of apps here. There's OTA 0, OTA 1, which is short for over the air. So those are spots that like we could put the main application in. So we have 2 of those, so that you'd actually have potentially 2 versions of CircuitPython next to each other. And the stage 2 bootloader's job is to decide which of the 2 to use. But then there's also a third option, which they call factory, which is the kind of like fallback thing that runs by default if the OTA stuff doesn't work. And the factory thing should not be kind of like updated at all. It should just be fixed, ideally. And so that's the place that we're putting the UF2 bootloader in. So the way that it works is that the purple LED is actually implemented in this stage 2 bootloader. So when it shows purple, if you do boot 0 or reset should work if it has the extra capacitor and resistor. Otherwise, you could just use boot 0, which I think is going to be pretty common. When the bootloader sees that, it will jump to the factory app and not the OTA stuff. And that will be in your UF2 loader that comes as that boot drive. And then you can just copy, I guess I should show the full thing of it. So here we have the Sala 1R boot drive. And if I just go to, I'll snag the latest CircuitPython from S3. So every time we have a commit merged into the main line of CircuitPython, we actually build it. So if you want to try the absolute latest thing, what you could do is you can go here and do Espressive Sala 1 Rover, and then pick your language. If you didn't know it, CircuitPython supports a bunch of different languages. So all error messages and like messages about what's due are translated thanks to our translators. I'll just pick ENUS. Microdev says, can we have a UF2 firmware flash with make command? The UF2 build, or the make command to build, will build you a UF2 as well. So here we can actually try RC0, even though the website doesn't have it yet, which we'll get back to in just a bit. So if we go here, yeah, Unexpected Maker says, I can't get any combo of button presses to do anything using the UF2 that was built for my Feather S2 from the latest pull this morning. Yeah, I mean, like most ESP32S2 stuff, I would use the printing to the UART to debug what it's doing. So if I just pull up the Sala here, this is another way to get to the, you can see that it's still beta 2, not RC0. But you can do the absolute newest and you'll get to the same spot that I was just at. So let me download this UF2. And it looks like it's downloaded. So now if I go into my downloads, and you can see that I always download lots of stuff. I should be able to copy this over. Copy, copy, copy. It's flashing yellow. So that's it writing to the flash. And it's a large flash, so it takes a little while. Okay, so now it restarted. Blue to green. So blue is actually, I think, writing the CircuitPython file system. Or doing a delay at startup. And now we're green again, and CircuitPy has now shown. So now I can see my file system, and I could do normal code.py stuff. So that's the pitch for UF2. The other interesting thing, since we're talking about UF2, that I should point out is, as Unexpected Maker said in the chat, we don't have support for the APA 102, the dot star, into the UF2 yet. Everyone who videos needs that black LED acrylic to show LED colors on camera. Yeah, maybe I should like make a feather sized one, so I can like attach it to a feather. Okay, so that worked, which is good. I don't know why the double tap's not working. Double tap of reset. It's still early, obviously, but we do have, so talking about dot star support, we have dot star support for like the SAMD21 and the SAMD21 and the NRF52840 bootloaders already have it as well. So if you just go to adafruit.com or github.com/Adafruit and just look for UF2, what you'll find is that we actually have 4 different repositories for UF2 bootloaders, which kind of has driven a spike through my head because of things like this, of like supporting the non like flash writing stuff. So we have SAMD21 here, we have STM32F, we also have an NRF one, but obviously it doesn't have UF2 in the title. But then this tiny UF2 one was like Arturo's attempt at my request to create a tiny USB-based UF2 bootloader that would be easier to port from one platform to another and ensure that the experience of the bootloader, like what all of the LEDs are, is consistent across all of them. So we're still working on that, but TAC has actually already started from my understanding. So if you're actually on the ESP32S2 repo for UF2, and you look at branches, there's now this generalized bootloader branch, which doesn't have this file that I was looking at. So let's just go back to the top of it. There's this generalized bootloader branch here, and you can see that TAC was even working on it yesterday. He's working on making like one UF2 bootloader repo to rule them all. So that the hope is that like we won't have to like implement all of the LED stuff for every different thing. And TAC is working on that right now, which is exciting. Yeah, and Unexpected Maker says that's the only reason I'm not shipping it is because there's no user feedback. Yeah, it shouldn't be too hard to add if you wanted to try it. So under components here, there's bootloader. This is the second stage bootloader. And then subproject and main. I think this is where it is. And if we look here, factory reset. Check to see if application wants to load the UF2 bootloader with a reset reason hint. Or check if GPIO 0 is pressed or a 1-bit RC filter on a specific GPIO detected double reset. So this is the bit right here where that double tap logic is happening for the S2. And I don't know where there's a board LED on. So maybe that must be specific then to the individual board, which is in here. Oh, there's no C file in here. Anyway, it's somewhere around there, board LED on. So yeah, here's pin NeoPixel, board init, NeoPixel init, NeoPixel set, board LED state. Adolnix. Greetings, Scott. I was curious when using CircuitPython in general, but specifically with the S2, is it possible to use the status and control lines of the UART? I know it can be done in Arduino, but I've not had much luck figuring out how to do it with with figuring out how to do it in CircuitPython. Okay. And Melissa got her e-ink. So if there are any e-inks left and you want one, there's 3 left. Okay, so let me take a time code and I'll answer Edelneck's question. 3529. RTS, CTS, and UART. Okay, so I think the answer is we do have it in the API, but it's not super well supported across ports. So let me show you. Let's start with read the docs.io. So this is our like canonical. Max Payne Life says is there any way to use Arduino libraries with CircuitPython? There is not, but we have most for device drivers. We have our own versions for most of the stuff. Okay, so if you're looking at the API docs here, you probably want to do latest. Once we go 6 stable, we'll update this, but it defaults to the latest stable. And you could do core modules, bus IO, UART. Oh, that's board UART. Bus IO UART. And then if we look here, this kind of like documents all of the possible arguments. And we can see here that it does take RTS and CTS pins. So that is the way that you should be able to use it. I guess you don't control them directly. You could just do that separately with a digital IO. And then to talk about whether it actually works, no DCD, but I could probably work around that. Yeah, I don't know much about UART. If there should be a DCD here, you're welcome to add it. But I don't know a lot about it. So if we wanted to answer the question of like whether RTS and CTS work in a particular port, my way of doing that is just looking at the source. So if we just go here, we go ports. So this is the CircuitPython repo, ESP32S2, Common HAL, Bus IO, UART.c. What we'll find is that we'll find that construct looks awfully similar to the docs that we had, except it's like a C version of that Python stuff. It matters a lot on retro machines, which are slower than ESP32S2 in most cases. Ah, interesting. Yeah, so tangent time. My uncle has a Heathkit, what is it? Hold on, I'll pull it up in my email. I've been meaning to get back to him. So he has a Heathkit that's actually both like 2 computers in one. Oh, it's a Z89, that's what it is. And he has these like giant 8-inch floppies that he wants to be able to read. So he has one of these, and I was like, oh, I know how to interface with serial. So if you have something to interface with serial from old machines like this, please link me to it. I need to check in with him and see if he actually got any further with it. I hope he did, because I've been really bad about it. But he he actually had like a small business, and he's got all these old floppies that he wants to pull the data off of. Which is another cool tangent. So if you're in UART construct, you can basically see what happens. That's an H89, build one myself. Ah, thank you, DCD. So basically I'm just seeing if anything happens, and it does look like on the ESP32S2, like RTS and CTS will be used if you provide them. Otherwise, it should raise an exception. But yeah, it looks like it does get used. UART set pin takes in RTS and CTS. Okay. Electronics is fun. Adolnik says, I helped with the hardware and software on this, and we want to make an S2 version with CircuitPython. Awesome. Basically, a Wi-Fi enabled modem so you can telnet or netcat to or from your retro device. That's super neat. Guru modem. Yeah, that would be awesome. I love seeing CircuitPython on all sorts of stuff. And in fact, we just got another board that just squeaked in for 6.0. It's another satellite. If we look at, yeah, I'm getting distracted as always. Max Payne Life, I kind of skirted the question of how to use Arduino libraries with CircuitPython. So Seed Studio, actually, let me take a time code because time codes are helpful. 4107. Arduino libraries in CircuitPython. So the answer is no for CircuitPython, but Seed Studio has been doing this, has this really interesting thing called ArduPy that they've been working on. And it's a mishmash of Arduino, CircuitPython, and MicroPython, I believe. So you can see here it's from machine, so that's the MicroPython API. Yeah, so Seed's been doing some interesting stuff with this ArduPy if you want to like mash the Arduino world and the Python world together. I've not used it myself, so I'm not sure how it works. But I'll put that in the notes doc. Just if you're curious, maybe you have a lot of Arduino code, like that's something to take a look at. My bias is definitely just like CircuitPython is the way to go. But that's something worth looking at. Okay, so let's circle back to more our release candidate stuff, because I actually want to get it out. That's like my highest priority for this stream, because I'm not going to be working much longer after the stream. So let's just take another time code. And let's just get it on the website. So we have release notes, and I'll reset the zoom. We had 4 boards added. These BH dynamic ones, which page not found because they haven't been added to the website. No worries, unexpected maker, for distracting me. That's kind of like some of the best content I think in this stream comes from me getting distracted by things. And I think that the timecode thing is just a way to like organize that distraction and make it more useful. So I'm happy to answer questions and everything. Because like the things you have questions about are probably the things that like we need to better document, and what better way than to do a live stream with a timecode to it. Okay. So we have release notes. But the website's not updated. I did want to show off these satellite things, which is cool. So if I just go to close pull requests, we can see that these just came in today. And I don't know if they actually have a link in here. I know that there's an issue, a closed issue that they filed. Like they asked for a VID PID. But then it turned out that they got some from Microchip, so they use those. And in fact, news on the USB PID front, I actually have write access to PID.codes now as of last night. Unfortunately, I want to get that giant aggregate PR in before I start doing individual PRs, and I can't approve and merge my own pull request. So I emailed Nick, who did the site originally, and hopefully he'll either approve it or just give me more permissions. We'll see. So yeah, this is the latest satellite that runs CircuitPython, which is super neat. You can see some pictures here. It actually, this form factor looks so much like the form factor of my drone boards that I did, which I thought was really interesting. The idea of doing this stack. I didn't use these headers. I used a high density thing instead. But yeah, these are CubeSat boards, and it's actually two different boards that both run CircuitPython, which is pretty wild. So those snuck in under the 6.0 deadline, which are pretty cool. Yeah, so I'll just drop that in the notes. And if you didn't know, Chickadee Tech is the name of my company. So I technically contract for Adafruit, and my website doesn't have much on it. But this is the board I designed before Adafruit with an STM on it. And you can see the high density connector there. And then this explains, I think I really well engineered it. I just didn't, like, the business side wasn't strong. Like, it was just very costly for, like, the whole market went towards all-in-ones where I was going towards modular stuff. But this is kind of what it looked like on a quad frame. Nice. Alvaro is going to work on a nanosat too. Invalid header. The latest satellite that runs CircuitPython. I know. I linked them to the other ones. They were like, oh, cool, but those aren't CubeSats. It's like, all right. Yeah, I don't know why you're getting invalid header. It sounds like it didn't flash right. Okay, so let's just finish the release first. I did want to talk about a few of the fixes that I did to it. So congrats to Unexpected Maker. Again, as a side tangent, the Feather S2 was stocked by Adafruit this week, and they're already sold out. So congrats to Unexpected Maker for the Feather S2's success. Somebody asked me a question while I was thinking about that. Okay, so Max Payne Life has a question. Says, the Mars Curiosity has dual computers for hardware redundancy, allowing it to swap. Is there anything that like that exists with Arduino, ESP8266, or ESP32? I don't think so. I think like you would get that sort of redundancy kind of like outside of those two things. I don't think that any of these satellite projects expect to be like in the like flying around the Earth for very long. So I don't know I don't know that like the dual thing. I do know that one thing that Max Holiday, who's the other guy that did satellite stuff, I know one thing that he added support for is so if you go to downloads and it's the Pi Cubed is his thing. So he added MRAM support. So instead of SPI Flash, MRAM I guess is it's magnetic RAM. I think it's a bit pricier, but it turns out that it's like more hardened against radiation. So they added MRAM support for that reason. Alvaro says, most of the first satellites use separate computers and sensors and do voting on results and go on quorum. ASM 2750 says it's magneto-resistive memory. Awesome. Okay, let's get this release out. I have one task, and it's finishing the release. David G says cosmic rays is the problem. Okay, so how do we get it on the website? So if you look at circuitpython.org's repo, which is all open source as well, there's the circuitpython.org repository, and we automatically create a pull request for the new release. So the CI for CircuitPython, when it's a release, will also make this pull request. It does require a manual step where I download all of the server logs essentially and add download counts. So it's a giant change because the file includes it includes like all the URLs for all of the different downloads. Maybe if we click here, you can see it. Yeah, so this gives you an example of what this file looks like. So it's a giant file. It's almost a megabyte. But you can see that for every board, we have a download count. And the reason that we have that is because we sort CircuitPython downloads by default by download count. I wanted to make sure that like try to make it as like fundamentally agnostic to manufacturer. So that's why like the Arduino shao we see here is up in this top. So it just goes like this way in terms of number of downloads, and that only is applied to the latest stable and the latest unstable. So that's the it's not overall lifetime download counts, it's download counts of the last 2 releases. Trying to be like more like we don't want to penalize new boards that much. So yeah, so these are sorted by download counts. And the way that works is through this file, which is a giant file that has all of the boards and all of the files for each board. And you can see that like, here's the links for 531. Here's the links for 60RC0. And we tend to review our own stuff. It's created by a bot, so I'll approve it. And actually, before I do that, I should check the release build. So this is GitHub Actions. This is how all of those artifacts are built. And it looks like everything passed. If I just refresh, we have a green check mark, which means that all of the different boards and all of the different translations did manage to build, and it all got uploaded as well. So if I merge it to the website, when people click download, they should actually be able to download it. So here's the page. I'm going to keep this open, and then I'm going to merge here. And this will release the RC0 to the website. Look at me at 3 o'clock on a Friday releasing a new build. It's a pre-release build though. And we're pretty confident that it's stable. So there's just a little lag between when it's merged and like there's another kind of CI process here that regenerates the website. So the website is actually all statically generated. And so that will take just a couple minutes, which means we can answer Mark's question. I think it's Mark. After we take a time code. So Mark asked in the YouTube chat, platforms like Espressif have an underlying RTOS. There are a number of good free and open source software executives, which I think you mean just alternatives. Have you ever thought about adopting an RTOS for the foundation of CircuitPython? Dan and I have discussed it a bit. And Adafruit is actually a member of Zephyr, the Zephyr Foundation, which is kind of one of the newer, more popular RTOSs. And we looked at Zephyr, and I think the trade-off is that like a lot of RTOSs. So to back up, what is an RTOS? It stands for real-time operating system, and the core of what it provides you is a way to like do concurrency and like primitives to do concurrency well. There are two kind of models of concurrency that you can have. You can have preemptive, which means at any point you can be interrupted, or you can have cooperative, which means you say like, okay, you can interrupt me for this period of time. Cooperative is good because you make clear when you get interrupted, but that also means that you may not like if something has to happen at a particular time, it's harder to make that happen. So we did talk about it, and the question is kind of like I like the idea of, yeah, NWK says RTOSs give you deterministic latency. Yeah, so the question is what do we gain from adopting an RTOS? And we've never promised deterministic latency on the outside, from Python land. It's certainly something that comes up more as you start talking about networking, because networking under the hood requires a lot more determinism. I wouldn't rule it out. The thing that has kept me from doing it is that it's a lot of work. Particularly Zephyr. So the things that I've kind of looked at is like free RTOS is something that is used by the IDF. The ESP IDF uses free RTOS, which has been around for ages. And it does have just like this core, what it's called a scheduler, which determines what runs when. And in fact, on the ESP32S2, like free RTOS is running, and CircuitPython is running in a task from free RTOS. But like all of the stuff that CircuitPython does runs in the same task, except USB has its own task. Yeah. So Mark says, getting so many new boards for free is another awesome benefit of Zephyr. I don't know how many we would actually get for free because we require metadata that they may not have. One of the blocking things with Zephyr in particular is, and so here's a general problem that we have. CircuitPython is much more dynamic than the vendor HALs that are usually provided. And like free RTOS really is just the scheduler, which is like what runs and some blocking stuff. But other real-time operating systems are really trying to be platforms, kind of in the same way that CircuitPython is trying to be a platform, where they have lots of boards supported and they have drivers for I2C and SPI and Bluetooth and all that stuff. So that is, yeah, it's a lot of work is the gist of it. And it's not exactly clear that these things work well. So like a lot of what people need to do with embedded is just fixed function sorts of things. Like I'm making widget X and this pin is always I2C or this pin is always SPI, which means that like the HALs that vendors provide and the RTOSs that are designed for it more broadly, like they just give you like, there's a lot of configuration that happens at compile time, which we simply cannot do. So there is currently discussion. So I know Mark is a fan of Zephyr. Both Marks are a fan of Zephyr. And so Adafruit joined the Zephyr Foundation, and as a result, they got a spot on the technical steering committee, which is kind of like the high level technical board sort of thing that makes some decisions about Zephyr. And so I actually go to that. So I actually like am a member of the technical steering committee for Zephyr. And I was actually having some discussions with Maureen Helm, who's the chairperson, I think is the right term, of the steering committee. And she was her and I were having this discussion of like, would we think about using it for CircuitPython? And my kind of answer was like, it's not clear that we gain a lot from it. And there's a lot of work that has to be done as a result. I also know that there's ongoing work. I think I saw this somewhere. There's ongoing work to make the IDF, the ESP IDF agnostic. So it could use Zephyr instead of the free RTOS. And that would be really beneficial for us, right? Like, I don't think Zephyr has ESP32 as like ESP support generally right now. So like we'd still have to have this like non-Zephyr world as well. Bruce says, I went through the entire Zephyr clone and build process a few weeks ago. I was surprised it all worked. Yeah, so the other thing is that like a lot of the Zephyr documentation is also geared towards like blank slate sort of projects, and like we're definitely not that. So like there's this whole question of like Zephyr has its own package management and build system, and like how does that integrate with the build system we have in CircuitPython? Mark says MicroPython has a Zephyr port in case you didn't know. Yeah, and you know who's been working on that? Maureen. So I'm actually I'm actively trying to get Maureen interested in CircuitPython, hoping that she'll work on a Zephyr port for CircuitPython, bring that over. But it's her pet project, so she doesn't have a ton of time to do it. But like, this is one of those long-term things that is like in the back of my mind that like, yeah, we probably want to do in the long term, but it's hard for it's hard for me to advocate that we do it for Adafruit broadly, because it's just, there's so much work to do that's not that has more immediate payoff. So for those of you who like Zephyr, make it happen. The problem is like, I also don't know a lot of it. All right. Like there's a lot of like technology that or patterns that they borrow from the Linux kernel that I just don't have experience with. So there's just like this huge ramp up curve. So Mark Roberts, I hope I answered your question. Is like, I wouldn't rule it out, but like, the foundation of CircuitPython is MicroPython, and MicroPython has always had its own like super loop, if you want to call it that. So yeah, I wouldn't rule it out that we would do it in the long term, but the short-term gains are unclear. I think the thing that could drive it to us most is like, if we're doing networking on most things or Bluetooth on most things, like Zephyr has the benefit of like people who are working like on Bluetooth are actively implementing new stuff in Zephyr, like private Zephyr, before it's released. So like, I expect Zephyr to be like on the leading edge of Bluetooth tech. So that could be a reason that we want to go there. Jonah asks, what do you mean by a super loop? So what I mean by a super loop, so I talked a little bit about this idea of a scheduler, which is like the core of RTOS usually. And that's the thing that's deciding what you do. And a super loop is a term that I've heard for like, you don't have a RTOS, you just have one big for loop that you manage yourself, of like making sure that this thing and then that thing and then this thing and then that thing. It's kind of like a super loop is like one top level loop that controls what is running kind of like manually, rather than using an RTOS to do it. Okay. Mark says LoRaWAN is being actively developed for Zephyr, which is awesome for me as that's what my work needs. So Pavre6 asks, can CircuitPython run without an RTOS? If no, why? Yes, it normally runs without an RTOS. Yep. It kind of like Sandy 21, Sandy 51. NRF is a little weird. ESP is a little weird. STM, so Sandy STMs don't have RTOSs at all. So what happens is like, I think I showed it last week. Like, if I had to point to what the super loop of CircuitPython is it's in that like main file. Like in here, there's this for : like, see here, this is an infinite loop. Like, this is the top level loop for CircuitPython. This you could think of as, I think, like the super loop of CircuitPython. And MicroPython has this equivalent, like we inherited that. MD Roberts 1243 says, LoRaWAN is what my work is. Lots of LoRa fans. Only boots and mounts the UF2 drive. Unexpected Maker, did you copy a UF2 on it? Okay, so that's Superloop. And thank you. Somebody else took a time code for me. I appreciate that. I double checked it with mine and it looks okay. Okay, so let's refresh the downloads page. We've talked long enough that this should be applied. So let's just double check. So if I just hit refresh here, we should see the boards potentially shuffle in order. And we do, because we see Trinket here is second. See the Chow is in the same spot. Let's just click in here and make sure that we do now have a 6.0 RC0. So we're almost done with the release, and maybe I should have taken another time code. I'll just call that 105. Checking on release. So there's two more things I have to do. Do you know what it is? Anybody have an idea of the two last things I need to do? I don't know if any of you see that. FoamyGuy says, do you know if there's a trick to using both screens on the monster mask? I don't. I know somebody else added the support for the second display, and I would have expected it to just use right display as normal. It's possible it's broken. Like, it's tricky. Yeah, and definitely have two different groups for each display. Okay, so the last two things I have to do is I make a forum post and I make a blog post, basically announcing it, right? So it's out, you can download it, it's on the GitHub page. The GitHub page also always happens first because because that triggers the build for everything. And then we have a chance to update any released note stuff that we want. But the last thing to do is to do a blog post and a forum post. So let's just get that done. So here's the support forum. If you don't know it, you should check it out. It's a good way to like get longer term help. Discord's great if you're going to be online for the next couple hours and somebody replies to you. But if you have like a multi-day sort of thing and have pictures and things, like the forums are really good for that. So you can see here we have CircuitPython 6.0 Beta 2 released. I like to do posts here, both because it makes people aware, but also that it's a one spot people can like reply with issues. So we're just going to post a new topic here. And I've got to, so one of the things that makes this hard is that the forum has BB code and the blog has HTML. So what I do is I copy the release notes, Control A, Control C. I'll create a new file and save it as rc0.md. So it's markdown from GitHub. And I can do here, I can do Python tools, convert release notes, rc0.md. Had to source some Python environment to give me. So this is a converter that converts Markdown to both HTML and BB code. The only thing it doesn't have is the link to the release notes. So I just paste it in there and I go back here, copy, and then it's CircuitPython 6.0.0 release candidate 0 released. And we'll make it an announcement and preview it. So I should say, if you haven't gotten it, if you're watching this stream, that means you're kind of into things. You should try upgrade all your projects to RC0. Let us know if any of that doesn't work. Basically, the process going forward is that if we get everyone to try it for the next week, nobody says, hey, this thing is broken. What we'll do is we'll just literally call this version 6.0 and then go from there. So we think it's stable. We want to give it some like time to find out if it doesn't work. Unexpected Maker says, yeah, it's working now. Wicked. Awesome. Yeah, UF2 is great. Okay, I updated the link, and so you should all download it and try it. And it looks okay. Like there's no egregious formatting issues, which can happen. Double pass IO0 goes into UF2 mode, otherwise it boots okay. Yep, that's how it should work. Yeah, you should do reset IO0. Reset IO0 should get you into UF2. Okay, submit. Okay. And then what I can do is I can make this. This is the previous one. I just make it normal rather than announce. So the post still exists. It just doesn't show up at the top. And I don't have any forum replies to do. And then the very last thing, and I'm just going to move this off temporarily. I think I can show it. I was thinking about this. So the last thing to do is blog it up. Let me just make sure that I'm logged in. Yeah, I think this is okay. I think I could show all this. So blog.adafruit.com is WordPress. Pavre6 says, I have an F4 discovery on my desk. Can I try this version on it? Yes, you can. What you do is you go to the download page, and then I think if you just look for STM, you'll find the F407 discovery kit, I think is what you have. Just go there, and you can download the bin, and then you need to use the DFU. I think it's DFU. The native bootloader to download it. We do have a UF2 bootloader for it, but we don't kind of demonstrate how to use it very well. Okay, so I was blogging, and I can move this back. So I'm just going to do posts, add new post. And same deal here, CircuitPython 6.0.0. These candid 0 released. Toddbot says, congrats. Thank you. I wanted to do it this week. I don't think we'll talk much about sleep stuff, but I do want to go over like some of the interesting bugs that I fixed to get us to the RC point. So just going to call it CircuitPython, and I'm going to add some media. And I think I could just do mine, because I just want to reuse this banner. So that'll put a nice picture at the top, and then we're going to go back to our terminal and copy. Above this BB code version, there is an HTML version. So I copy that. Ooh, hopefully it didn't. I keep copying. I have like 2 different hotkeys for copying. It's ridiculous. Okay, and then we need to copy the URL. And if Twitter is up, this will tweet as well. So now we can preview. And we can see the nice picture here. If you like that picture a lot, I'll plug the fact that you can buy a poster of it. If you look at new products, it's under here. So there is a CircuitPython 6 poster you can buy if you like that design, which I think this design is my favorite so far of my version pictures. Where did I lose it? So this looks good. I set a category, which is good. The rendering looks okay. We can always go back in and edit it if something really bad's in there, but yeah, that looks good. So let's wait for it to come back, and we'll publish it. Hopefully there's no typos you saw and you like are typing about it right now. Awesome. So now if we just go to blog.adafruit.com, it might be cached. Or why is that the preview picture? It should have snagged this, I think. I think what we could do is we can double check. If we go back to it, and we can set the featured image. I think this is how you do it. Set it to that as well. Hit update. I think that's how you do it. And of course I closed it. What does by Scott edit this mean? Oh, here? Well, I think this is like showing that the author and then edit this because I have edit rights. So if I wanted to edit the post, that's where I would go. But it looks good now. I love that banner. Bruce did an awesome job. Cool. Okay, so the release is out. We're done. So close to having a like stable version. All right, let's, did the tweet go out? I don't know. Bruce banner. The designer who made the banner, his name is Bruce. Looks great, too bad CircuitPython is spelled wrong. Haha, JK. Thanks. Thanks, Todd. Okay, I just wanted to briefly go over, now that the release is out. Oh, Alvaro asks, how's the puzzle? Mark says tweet is out. Kimo says, awesome, just waiting for some boards to try MicroPython out. Are they shipping to you, or do you have to decide which ones to get? Puzzle-wise, I've made slow progress. I should post another picture on my Twitter. I don't know what the pieces of the CPU are, but there's like, I think it's probably RAM kind of in the middle, and I got most of that. Nice. Yeah, I'll tweet another picture. It's kind of off and on. Oh, yeah. Oh, I should plug this. This is really cool. So let me, I don't know if folks saw this article yet. So Jay Carlson is kind of epic. He's very epic, actually. Not kind of, definitely epic. He originally did this article on the $1 microcontroller, and he just published today a like very, very, very in-depth overview of Linux, embedded Linux. So I'll just drop that in here. Kimbo says, as an electrical engineer who's worked with Python and IT for the last 6 or so years, it's time to get back to MCUs. Awesome. What boards did you get? Let's see. I'm great at getting distracted here. 1850. We talked about it before, but I had this desire to like get CircuitPython with HDMI at some point. I still think the right way to go is Raspberry Pi. And where did oh, it's here. But this is an amazing overview of like some very common chips that can run Linux on them. And there's no reason we couldn't run well, it's a lot more work to run CircuitPython on them because they're more complicated chips. But that's kind of I read through this with that view of like, what if we took one of these boards and put CircuitPython on it instead of Linux? Because yeah. Mark says, I literally spent some hours going through Linux capable boards yesterday and have been doing that during this stream also. Yeah, I think the Raspberry Pis are still probably the right way to go to get to start doing the better ones. But waiting for some PyCon boards for the connectivity and the Huzzah boards. Cool. So you'll definitely be using MicroPython then, the PyCon version and the regular version. Yeah, so this is a very cool article. It has a lot of details. There's one particular spot about MicroPython that I thought was a little unfair, because they tried to argue that oh yeah, here we go. Bare metal MCU development is primarily done in C and C++. Yes, there are interesting projects that run Python, JavaScript, and C#/.NET, and other languages in bare metal, but they're usually focused on implementing the core language only. They don't provide a runtime that is the same as a PC, and even their language implementation is often incompatible, which is a link to MicroPython docs, which I'm like, it says that means your code and the libraries you use have to be written specifically for these micro implementations. As a result, because you can run MicroPython on an ESP32 doesn't mean you can drop Flask on it and build a web application server. By switching to embedded Linux, you can use the same programming languages and software libraries you'd use on a PC, which is totally fair. You can't run Flask on MicroPython or CircuitPython, but if you read further down, and I forget where it is, they start to talk about the fact that some of these Linux class things can't run it either because they don't have enough RAM. So it's even when you have Python, that doesn't mean that you have enough RAM to run the things that you would normally on a regular computer. So that irked me a little bit. But I kind of get the point. I'm biased and I have a love-hate relationship with Linux. They make the argument oh, it just works, but then go into all these details that you have to get right in order for it to work. But it's a really interesting overview. I haven't even read the per chip sort of stuff. It's super in depth and a great primer, I think. So I read most of the start here, and then I was like, I got to do some work today. But yeah, how would you educate the author and reader of the Linux article? There's the discussion section. I don't know. I think I think it's just that you should give MicroPython deserves more credit to be being real Python, I think, and by extension CircuitPython. Yeah, you can't run Flask, but it's not the language's fault that people write giant Python libraries, right? It's simply a matter of you have all this room and you don't have to worry about it, right? That's not the implementation's fault. Jonah said that would be awesome. Would CircuitPython replace RPyOS? Yeah, that's what I would love to see. I would love to see bare metal CircuitPython running on a Raspberry Pi. In particular, I'd love to see displayio being output to an HDMI. Pis are not open source. I've always leaned to Beagle and compact Beagles. Yep. True. Octavo Systems does the STM32MP1 thing a while ago. Nice, but still BGA. Yeah, I mean, I got through parts of this article. They cover how to solder BGA and how to route them. So they address that. They also address DDR3 RAM, which is really interesting as well. So if you're at all interested in this is a really awesome resource. Each of these boards was designed across 1 or 2 days worth of time using GLC's low-cost 4-layer PCB manufacturing. So like, that's super cool. That's super cool that like they look like Jay, who wrote this article, really took a like look at it and said like, what is the bare minimum I need for these things, and how does it vary between these chips? Kimo says the compute module for Raspberry Pi is really good if you're creating a base for yourself. I have the CM1, the official dev board, but I guess I should invest in CM3. Look into Balena Fin for development. Brings many things you want, include your own baseboard. Jonah says, heck yeah, having CircuitPython on a 1 gigahertz board would be awesome. Not to mention megs of RAM. Gigs of RAM. In this example, he talks about DDR3 chips can be up to 2 gigs. Mark says, I just realized he made all those boards. He's crazy, but awesome. Yeah, this is a really good primer. Like, I didn't mean to, like, I had one paragraph that I was kind of, like, irked by. There's been some interesting... So, the way that operating systems work is that, like talking Linux-wise, like, they're going to give Python, like, a fixed amount of time to run and then switch to something else. And I'd be really curious to compare performance-wise, like, bare metal. Like, how much performance do you get back if you don't have the OS underneath you? It's kind of interesting. There's been some work, I think, either with Go or with Rust. I think it might have been Go, where they actually got the Go runtime running, the same runtime that you could run in Linux, also running outside of Linux, and comparing the performance, and they actually found that it was like pretty comparable, which is really interesting. So like, how much performance you get back by being bare metal? It's not necessarily that much. So talking about CircuitPython and regular Python on a Raspberry Pi, like, it may not be that different, except for the fact that like real-time stuff is less real-time. It's an interesting thought. All right. That's a plug for that. We've got a half an hour left. I was going to do sleep API stuff, but I also wanted to talk about 3 bugs that I fixed. Let me just preview those bugs, and then people can tell me if they're interesting or not. Okay, so the 3 bugs, what I have here is just the recently closed pull requests. We talked about the satellite stuff. Dan enabled the BLEIO HCI support on all the boards that it would fit, which is really cool. So if you don't know what this is an implementation of BLEIO that uses an external BLE chip, particularly the ESP32, no S2. You can load firmware on the ESP32S2, and that will act like a normal like BLE HCI device, which is a common way of talking across like a bridge. So that's really cool. And it's still early days, but potentially like all those boards that we have ESP32s next to SAMDs, SAMD 51s, like theoretically we'll be able to do Bluetooth instead of Wi-Fi on those, if that's what you want. Okay, let's keep going down. Translations, board stuff, Ask Patrick and Microdev did this LWIP hostname stuff. So when your ESP32 board, S2 board is connected, you'll see like a friendly name for it. And Unexpected Maker set it for his boards as well, which is cool. Gambler did some build stuff. Jeff fixed some terminal things, thanks to C. Walther as well for helping with that. So here's one that I fixed, which was STM sleep too long. This is kind of a follow-up to a previous one, but basically, if you did a for loop of like 10 items and then slept for 1/10 of a second, the for loop would not take a second. it would take like 7 seconds, which is definitely wrong. Johnny says, "Sorry, guy. Hi, guys. Sorry I can't participate today. Out bar hopping. Have a great time. Be safe. I don't know what the state of COVID is where you are, but hope it's not risky." Yep. Add method to set custom host name. Finer grains per port tick locking. So crash here. And Seville's donating. Thank you. I will answer you in just a second. There's one more. This one. So these are the 4 that I wanted to talk over if you're interested. So here's a preview. Then I'll answer Seville's question, and then we'll keep going. So I fixed auto reload on the SAMD21. So if you want details about that, let me know. I fixed some STM-RTC stuff that manifested as I2C issues, like raising exceptions when it shouldn't have. I fixed an issue where the pew module, which is like used for the pew. If we go back, pew. So this one in particular, I think, is driven by some like interrupt signals, and it was flickering with the new changes on 6.0. So what I found is that we had this like high level interrupt lock on SAMD21 that was like locking all interrupts for a while, causing like some like bad latency things. So that's this fix, and then this last fix is the sleep issue I was talking about. So if you want me to go into more details, let me know. And now I'll answer Seville's question after I take another time code. 131.52. Okay, Jonah's voting for sleepio stuff, which is the other thing you can vote for. We can move on to that. But first, let me answer this question. Okay, so Seville says, and thank you for the donations. That's awesome. Seville says, suggestion for starting point / tutorials to learn how to start translating over from Arduino sensors to Python so I can pitch into the CircuitPython effort. I am an enterprise dev using C#, JavaScript, etc. Good question. The first question I would ask is what sensors you're talking about. We support like 250 in CircuitPython already. And the way that you can check that is by going to the bundle, which is where we bundle all of the Adafruit supported sensors. So, and that reminds me, I have a good video as well we could talk about. So on all our repos, we usually have this doc passing, and if you click that, you go to the read the docs. And on the read the docs, we have this, which is a list of I think this is all of the libraries that we support. So the first thing is to just check to see if we already support the things you do. And at this point, I think we basically support all Adafruit products already. Like all sorts of stuff, which is awesome. So this is a great index. And in fact, let me drop that in the notes too, because that's a great resource. Some obscure sensors that aren't in CircuitPython portfolio yet, or if ever, and they're all Arduino compatible. Okay, perfect. Yeah, we're always looking for more. So if it's not in this list, then there's one other place to look, and there is the CircuitPython community bundle. Maybe I don't have it in my. There it is. Doesn't have the word Adafruit in it. So this is just like the other bundle, except it's not Adafruit supported stuff. So there's a few things in here. I don't know if there's a list like the other one. No, doesn't look like it. But you can look in this library's drivers and So here's all the ones here and here. So take a look there as well. So that is like how you check to see if it's already supported. And then resources to get started adding support. Creating and sharing a CircuitPython library is a guide that I wrote that covers kind of like all of the mechanics of creating a library and getting them in the bundle. That doesn't necessarily like help you kind of port ideas from Arduino to CircuitPython. I guess if you're just getting started with CircuitPython itself, a good overview that if you're comfortable with Arduino and want to kind of like see what the corresponding thing is this CircuitPython Essentials guide. So you can see like how to do analog stuff, how to do digital I/O. SPI is oddly missing from here. I think we should add it. But you could see here also like how to do I²C. So this is a really good broad overview if you're just new to CircuitPython. And then I've got one other resource I can think of off the top of my head. And if you have further questions, feel free to ask them. Brian did a talk at PyBay 2019 CircuitPython. I think it was just in we just put it in the newsletter as well. No, it's not here. Like I just had it open in a window. Do I still? Oh, I do. Here it is. So Brian goes by Sedacious, and he works for Adafruit and does a lot of breakout designs and the drivers for them, both Arduino and CircuitPython. So he did this talk called Accelerating Driver Development with CircuitPython. And it's an hour long. It's a presentation back when we got in person. I think I could actually tell me if this is too loud.
I'm slow. And I procrastinated. But
so there's a good talk here that Brian did.
The byte with the bit mask. And you write the...
And I heard that it's really good. I haven't actually watched it myself. So I would recommend that as well. I think that he covers... Adafruit Register is a library that we've created, which is a good resource as well. Can I post the link? Yes, they're in the notes doc too, but here's the link to the video. So yeah, I think that's a good resource too. Hopefully, Seville, is that enough to get you started? The other thing I should say is just the Discord. So join the Discord. You go to adafru.it/discord. We have two primary CircuitPython channels. There's Help with CircuitPython, which is like, I'm just using CircuitPython and I need to get something going. And then there's also just regular, the CircuitPython channel. That's more like development stuff. So trying to build CircuitPython yourself or trying to write a library can go there too. So that's where to get information for that. Okay. Ooh, nice. Alvaro is just posting this talk, a Spanish talk about CircuitPython, I think is what it is. Ah, nice. I know Eduardo. I met him in person. This will be a talk by the Electronic Cats crew about how to contribute to CircuitPython. That's awesome. Do you know which day of October it is? I assume this is October 19th through 24th. I guess it's on Eventbrite. Looks like they added the wrong people. Workshop. Okay. Yes, on the Discord. Perfect. Okay. nobody took me up on these bugs, so they're fixed. It's fine. It's in the past. So I'll close those and just talk a little bit about sleep for the next 25 minutes. 19th. Okay, so that Spanish language CircuitPython workshop is on the 19th if anyone is interested. Okay, I can close this. It's clearly not in the past. The bug issues? Hopefully they are. I mean, we're going to have new bugs, but these bugs are hopefully fixed. The workshop is not in the past. Okay, so one thing I did is, let me take another, well, a sleep time code. We have lots of time codes today, which is awesome. And somebody already took the time code for me, even better. So one thing I did is I've started with where microdev left off. Then no one took me up on them, so I did them myself. Yeah. It's in the past. Okay, I want to look at mine. So I basically use GitHub as a backup for myself as well. So I obviously have lots of branches, and I'm going to pull up my sleepio branch. Sybil says, I think you mean if they're interesado. I'll take your word for it. I don't speak Spanish. That's probably, if I were to make the effort to learn a language, I think Spanish would be the language I chose to learn. I took German in high school, but Spanish is far more useful in the US. Okay, so sleepio, and we could just compare to see what I've done so far. But basically, microdev was doing really good work in getting the very lowest level into the IDF working, but the higher level of the API wasn't really what I was thinking. This is going to crash. Todd says, why is your CircuitPython clone off MicroPython instead of Adafruit CircuitPython? Because one came before the other. I cloned MicroPython before CircuitPython even existed. But I can still... that's just kind of like the default. Like, I can still PR from my CircuitPython to Adafruit CircuitPython just fine. Yeah, I'll give us... Mind blown. Yeah. So... Okay. So these are the changes from main. They're not the changes from microdevs, which I could actually do, I think. Microdev. I don't think it's main. What does microdev call their branch? Sleep CPy, I think. Yes, let's talk about sleepio, which maybe I should update this issue as well. So there's two really interesting issues that are on my radar for this. One has the word hibernate in it. So after we have this other, we should add the ability to hibernate. So, yeah. So this is kind of what I had in mind for how it works. So these names are going to change, but this is the general idea of sleepio. So right now what we have in CircuitPython 6 is we have light sleep, which means that when you do time.sleep, we will do a light sleep, which is everything's still on, everything's still powered that was on because you turned it on. But the CPU itself is not clocked. So it's powered, which means it saves its state, but it's not clocked, which means it saves the energy of like changing the transistor states. Deep sleep and what I call hibernate in this is the idea that you can save a lot more power by basically turning power off to parts of the chip. And so deep sleep's goal is to, and the reason it's weird is that like you lose all your RAM, which you don't have to do, but you also lose all your CPU state. So what I'm thinking of is like there's two pieces to this puzzle, maybe three. The first is like waking up based on something that's not just a time delay. And then the other thing is like sleeping and shutting CircuitPython completely off and then starting back up. So I've introduced sleepio to do this sleep until alarm thing that I originally had on Supervisor. But I chose to do it as a separate module because we're very good at conveying to people like whether like having a module implies some like related support. So I want sleepio to be the like core module that says like deep sleep and light sleep to based on alarms as supported. So that's what sleepio does, and I'll talk in the diff kind of over it about it a little bit. But I got a question from David. David asks, I might need more stack on the QT Py. I got the runtime error maximum recursion depth exceeded. Yeah, so we have two stacks now. We have the C stack and the Pi stack. If you get to the bottom of the Pi stack, you'll get a Pi stack exhausted message. So it sounds like you're running out of C stack, which is configurable through the C stack is configurable through the supervisor. So if you do stack on next thing, I forget what it's called, on next reload, then that will change it, I think. On the SAMD21, which the QT Py has. So the way some platforms work is that if the stack lives in a separate memory from the heap, then the stack size will be fixed. So for like the ESP32S2, the stack size is fixed because it's running within the free RTOS that the IDF is using. So there's like a fixed C stack there, and then we have a separate variable for the Pi stack on the S2. We have a similar thing on the IMX RT where both stacks, the Pi stack and the C stack, live in the data tightly coupled memory, which is faster to access and not cached, but can't also be it can't be DMA'd to. Whereas the heap lives in OC RAM on the IMX RT, which is like, I don't know what OC stands for, but it's like slightly slower RAM, but it's bigger and can be accessed by more than just the CPU. Jonah says, is there a way to expand the Pi stack? Not dynamically, no. Right now it's just fixed, I think. Yeah. And both Jonah and Anecdata are pointing out that it's supervisor.setNext stack limit. That applies to the C stack only when you're able to change it. So SAMD21 NRF, 2151 NRF. I'm not sure about the STM. You share the heap and the stack. So if you increase the stack size, you reduce your heap size, is the trade-off you're making. Okay, so I think I covered the basics of sleepio. For light sleep, what I want to do is I want to say sleep until alarm, and then it returns the alarm that woke you up. So time.sleep is just like sleep for 10 seconds. It won't return to the code for those 10 seconds. Whereas what this is like, I want you to sleep until somebody presses a button. Or another similar thing is like if you have an accelerometer that's like trying to detect a fall or a tap, like it will raise a pin or change the state of like a pin when that happens. Like an IRQ is what that is. So you could say like, I want to sleep until this thing happens. And so what we're doing is we're doing this notion of like, broadly, this concept of an alarm is like anything that could wake you up from a sleep, right? Like when I'm designing an API, like it's trying to like correlate the concepts to something that like people hopefully are familiar with. So when we're talking about sleeping and waking you up from sleep, it's alarms that wake you up. So like microdev's done the under the hood stuff, but the alarm level like objects and things needed some work. So this is the light sleep version. You'll see that like this sleep until alarm happens in a while true loop. And a light sleep is characterized by like what I said is like it preserves the state of CircuitPython. And the corollary of that is that when you hibernate, you lose all of your state or almost all of your state. So basically what happens is that your code.py becomes the inside of your loop. So you have to import things again. There will be a way to get the alarm that woke you up. So it's not exactly the same object, but it like represents the same thing and should compare the same. And then what you can do is you can compare that alarm to the alarms that you are setting up, and you can figure out which one woke you up. And then this is going to change. I don't think I'm going to do it this way. But basically, before you deep sleep again, you have to set all your alarms again for when you wake up next time. So where am I at on that? I didn't get as much done as I wanted to. I think my brain is a little hung up on it. But here's the current state of, like I've done two changes on top of microdev's work. And we got 12 minutes. So I added a new type that is like a union type. So just in the docs, we have good typing. I'm not done with this one yet. So this is kind of where microdev left off. Where there's some like disable duration stuff at the top level of the module, which is just, I guess, just not like Python structured. And that's because they're a C person, I think. So I'm trying to help with like the API design level. And mostly when I'm designing or introducing new APIs, like this is the part I do first. I do the shared bindings part first because it's the part that's hardest to get right. It's the hardest to change. And I find that actually by starting with the APIs and the documentation, you can get a lot of clarity. And I think that's because it's kind of the hard part. It's probably also why I'm like kind of like procrastinating on it a little bit because my brain's still working it through. So that's why I'm in shared bindings land. The other thing that's nice about shared bindings land is that this is the bit that's shared. So like once we have this API for doing deep sleep and sleep, like it should be much easier to bring that support to other ports because you no longer have to have this like dilemma of like, what do I name things and how do I organize it? After shared bindings is set, like it's much easier to add support to other chips. Microdev points out it's what gets shown, which is important stuff. Yeah, so I did just start working on it. Obviously this has not been updated. Kimmo says, I do agree with that. Designing the API always helps to agree what needs to be done and how it's done. Yeah, so let's go down. Like some of this I'm just not done with. But I did start at the core. So here's sleepio initc. So this is kind of what Jonah was talking about, is like the core of it. And I just want to like, let me just read this because I think it kind of characterizes the way that I think about it. So what this is this is the like module level description. So if you're new to CircuitPython code, this prefix here, the // is a C comment with another prefix that indicates that it's a Python stub. So what it allows us to do is interlace Python stubs, which represent Python APIs without including implementation, intermixed with the C code that implements the conversion from Python land to C land. So what this is like in CircuitPython, when you do import sleepio, here is what like the top level like blurb about sleepio would be. So it says light and deep sleep used to save power. The sleepio module provides sleep-related functionality. There are 2 supported levels of sleep, light and deep. Light sleep leaves the CPU and RAM powered so that CircuitPython can resume where it left off after being woken up. Light sleep is automatically done by CircuitPython when time.sleep is called. To light sleep until a non-time alarm, use sleepio.sleep until alarm. Any active peripherals such as I2C are left on. Okay, so that's like, I said this earlier, but it's like, it's an interesting simplification, and I guess I could talk a little bit about how I'm coming down to this. Actually, let me read deep sleep and then I can justify it. So deep sleep shuts down power to nearly all of the chip, including CPU and RAM. This can save a more significant amount of power at the cost of starting CircuitPython from scratch when woken up. CircuitPython will enter deep sleep automatically when code exits without error. If an error causes CircuitPython to exit, error LED flashes will be done periodically. To set alarms for deep sleep, use sleepio.setAlarms, and they will apply to the next deep sleep only. So you may think, oh great, I want to try this, but this is just the docs that I've done before I've actually implemented it. This is me like figuring out what the API is by trying to describe how you use it. So what are the other things that I've taken into account? I don't think there's much. I think that's the meat of it, actually. I've done a little reorg. Like I've started to sketch out like here's sleep until alarm and here's set alarms and descriptions for each of those as well. But like this is very much I've tossed everything up in the air and I haven't like landed it down. Yeah, Seville says it's like a user story. Yeah, it's totally. And I think that I was thinking about this. Let me complain just a little bit. I don't want to be too hard on them, but so this is I hope you don't work for NXP, but I'm gonna do a little criticism here. So this is the IMX RT 1011 dev board, and I'd like. Oh wait, let me switch so you can see it better. So there are 4 buttons on this board. Which one of them is the reset button? I have no idea. I have no idea which of these 4 are reset buttons. You know why? They're labeled SW. They don't actually label the functionality of it. And this is a slight pet peeve of mine. It's a pet peeve of mine that like, this is a well-engineered device. It's the white one. Yeah, all 4 of them are white. Right? I believe this is a well-engineered device, but in my mind, it is not a well-designed device, right? And I think this is also what sets Adafruit dev boards apart as well. Like, you got to start with thinking about how you're going to use it. And a good way to decide how you're going to use it is also to explain it to somebody. So that's why I like starting with docs and the API level of stuff. I do get into trouble that sometimes because if I don't implement it the way I documented it, then sometimes they're not correlated. So yeah, I do get into trouble if I like write my aspirational docs and then I don't implement it exactly the same way and I forget to go back and update it. But generally, like this is the level that I start at, is like, what are the fundamental things that we need? The other thing that I do, and I think this is a good way to wrap up, is I also do an overview of kind of like all of the chips that I expect to support. So here's the weeds part of this discussion, the deep dive part of this discussion. So I actually created this doc yesterday as I was just like, I spent like 2 hours just like kind of researching. And I listed ESP32S2, SAMD21, SAMD51, NRF52840, STM F405, and the IMXRT. And what I wanted to get was kind of like, let me just read a little bit on each of the platforms and figure out how deep sleep works. Kimo says, does this effectively mean that all CircuitPython should be wrapped in try except to disable going into deep sleep? I hope not. I think that like if an exception is raised that would cause you to exit, there shouldn't be any cost to like exiting the VM. Should be like everything will get reset. And it should be okay if we deep sleep. I think the one thing that I've been thinking a lot about, and that's why I have this USB column, is like if you have a device that went into deep sleep and yeah, Microdev is asking why is USB no on ESP32S2. So this chart is what things can wake us up from the deepest sleep. This is a trade-off that I've been thinking about of like, CircuitPython is well known. You just plug it in on USB and you can see it. But deep sleep can't always be woken up by USB being plugged in. And so this is kind of me like discovering like what are the ways that we can be woken up from deep sleep. So the alarms will be broad alarms that wake you up from any sleep. But then when you call set alarms or sleep until alarm, they'll do extra validation on the alarms that you give them to make sure that it's possible to set all of those alarms or like an equivalent of that. And they might raise an exception, say like, oh, you can't actually alarm on that stuff. I've also been thinking about like what the time alarm is. So I think like time.sleep is relative sleep and it's light sleep. But I think that with the time alarm, we actually want it to be like a fixed time rather than a duration. As well. So yeah, this is me doing an overview. Microdev asked why ESP32S2 is a no on USB. And I'll see. Yeah, so this is meant to be all for deep sleep. So that blurb that I just said, actually, let me just read what Seville said. Seville said, this is a long-suffered problem in product design. The best products include designers to complete the circle that engineers start with excellent engineering and designers complete with great usability. 100%. I like to pretend I'm a designer. I worked pretty closely when I was at Google with a designer as well. And I think you get better things out of that. And I think Adafruit's really good at design because simply they start from guides. So like when Lady Ada Lamore is designing a product, like she's thinking about what guides can I write or have written for me? Like what projects can I make out of it? And that like you start, I think of it as like from the outside in. And so like for me as a CircuitPython Lego builder is the other way I think of myself. Like starting from the CircuitPython API, explaining how you use it, and then like looking under the hood as well, and kind of like normalizing things is kind of where I... Oh, yeah. Yeah, Kimo just asked if I could link to the comparison, which is definitely hard to come up with. Yep, it's right here. If you want to follow along. And that'll update as I work on it. That's the beauty of open source. So that'll be my branch that I'm working in until a pull request happens. Okay, so I just want to... It's 4 o'clock, so I'm just about to wrap up. But if you have questions, I'm game. I don't want to spend too much more time. I want to end it pretty soon here. But I just wanted to talk just briefly. The other windows I have open in the background here are actually the processor reference manuals. And you can see here that I have actually the clock and power management stuff. So this is the complicated one. This is the IMX RT, and I'm not sure I found a good table for it. I know the SAMD 51 better. Just figure out. Yeah, here's the SAMD 51. I made all my windows small because I've got to make them fit for the stream. But I just want to start, like, this is the... I think, you know, as a designer of embedded, this is the risk. You don't want to start here. And the reason you don't want to start here is because, like, this is the API for absolutely everything people want to do with a chip. And if you say, I want to expose everything from the data sheet upwards, like you're not abstracting anything away. And you're potentially spending a lot of time implementing things people aren't going to use. So I'm going to look at Power Manager, and a good PDF viewer that has these are really helpful. So there's some really interesting stuff here. And this is the table that is most relevant to our discussion. It's the sleep mode entry and exit table. Right. So it says what settings you set for different modes, and then how can you be woken up from them. And if you look here, it has idle, standby, hibernate, backup, and off. 5 levels, and I just explained to you that I was only going to do 2. And so the question is like, how am I going to how are we going to normalize to 2? From 2 API level things in CircuitPython to 5 levels under the hood. And I think the answer is like, we're just going to go to the lowest power state we can to achieve those 2 distinctions, right? Like, is CircuitPython still running when you wake up, or are you starting a new CircuitPython? Is like the core difference between light sleep and deep sleep. So what that means in terms of under the hood is that we do some smarts, right? Like, I think CircuitPython is actually potentially a really good option for people wanting to do low power stuff, because we do so much automatically. Like, when you need a circom for I squared C, that's when we start the clock up. Like, I don't know if we shut it down, but we should once it's reset. So like, whereas if you're doing this, like I'm doing a wizard and setting everything up that I possibly need, and I'm doing that once, and if you turn something on that you didn't actually need, like, or don't actually use, like, that's still going to be running. Whereas with CircuitPython, because like we have the system that does that as needed, like there's a potential there that we're actually going to be like easier to get lower power, right? Like, if we do it right, like we should be able to get lower power for the things that you're using, which is potentially really interesting. And it's also optimization we can do later, which I have to tell myself is that like, that's a great ideal. That's a great goal, but I don't have to do that today. I don't have to do that in the first PR. Like, the first PR can be about explaining what the API is, setting these like broad design goals, right? Like the goal of 2 levels of sleep, even though some micros have 5, like, and trying to set like the broadest high level of it to say like, this is the way that it interacts and what it means. The other thing that talking about what it means is that I'm thinking of the SAMD20 one, not the NRF 52840, but I think it applies to NRF 52840 as well. That like, I characterized the light sleep and deep sleep based on whether the CPU basically store its state or not. But the SAMD21 and I think the NRF 52840 as well, they don't actually like benefit that much from turning off the CPU, or there's like no way to actually turn the CPU power off. So Kim was trying to put something in. Anyway, I think that there's this like, the SAMD21 will always start up in the state again, and the question is, what does deep sleep mean if like the micro doesn't actually have deep sleep? And I think what it is like, if you're using deep sleep code on a micro that doesn't have deep sleep, what we should basically do is like I said earlier, like try to get to the deepest sleep state we can, given the alarms that we're trying to wake up to. So if you're doing bus IO SPY and then you exit and we're doing a deep sleep, like we should turn off all the clocks to SPY, right? Like, we'll get lower powers even if we're light sleeping by just turning stuff off that you're no longer using because you're not running your code. Okay. Yeah, so that's that. I did kind of a survey and I got it stewing in my brain, and I'm starting to spew it back out as API. But you'll keep a track on this. I know. Toddbot says I'm gonna pronounce sleepio as sleepio from now on, and I think I might have picked that up from Jonah actually. So IO is a common suffix we use on our modules just to make them kind of unique, and there is some like IO related to sleep here, so I kind of like sleepio. Seville says the converse of what you just explained seems like it would be that you wouldn't want to give 5 levels of sleep just because a few chips provide it, and if the majority of chips will be covered by 2. Yeah, exactly. So that's another tricky part of creating an API that works across platforms, is that you want abstract enough rules that it can apply in the same way across a bunch of different implementations. And that was actually one of my criticisms about the MicroPython APIs, is that they wanted to take the opposite approach of like, I want to be able to expose this one weird or different thing about I2C or SPI on this one particular chip. And I want to just be like, if it's only on one chip family, like I don't want that, because I want stuff to be portable. So yeah, figuring out what that commonality is really critical. Okay, let's look at what Kimmo's doing and answer any other questions, and then we're going to call it a day. And I will wrap up. But where did my comparison go? It is line 42 on init C, which is right here. Yeah, so this says, if an error causes CircuitPython to exit, an error flashes will be done periodically. Yeah, so this is what I was thinking about, and this is subject to change, obviously. But if your code is working, it should exit cleanly and then deep sleep. If it breaks for some reason, how do we let you know that that's the case? Currently, what CircuitPython will do is we'll repeat this LED pattern that actually encodes like the line number over and over and over again. But like, we don't want to do that when sleep is a thing, because flashing LEDs takes power. And in fact, having like a NeoPixel on at all takes power. So what is the right way to like notify you, like, hey, like I didn't end cleanly, in case you need to fix it, but also like still save some power, because like, you know, maybe there's some transient issue that caused you to raise an exception, and the next time it'll work just fine. So I think this is all like the corner cases of adding sleep support that we all can think about. And you know, as always, I would love PR reviews. So it's early, it's not even a PR yet, but if you have thoughts on APIs and things and corner cases, please let me know. But yeah, I think for me, thinking about that, it's like, it's a balance of like, if you're on cosplay, or like how do we notify you when something fails? Seville says, is there a GUI framework / library suggestion for CircuitPython? Shortest of answers is fine. So we do have displayio, which is kind of like the equivalent of display work to this that I did. It's like the lowest level of like allowing groups of objects. So it's like meant to build like widget toolkits and things on top of. And it's done like, we have a button class, and like Anecdata, I think, was doing some work of like organizing stuff. But it is kind of early days still. But displayio is kind of like the core of our display support. And that displayio core works across TFTs and sharp displays and e-inks. Yeah, so we'll get there. And FoamyGuy is typing. It might have been FoamyGuy working on that too. But yeah, check the Discord. These are great questions, and the Discord is a good place to check it out. Yeah, FoamyGuy says they're working on a way of specifying widget layout with JSON. CircuitPython display layouts. So you can specify what you want it where with that. So it's early days, and I know a lot of people like little VGL. So if somebody likes that and wants to bring it to Python, I'm open to it. But the way it's been brought to MicroPython by basically exposing C functions in Python is not what I want to do. I want it to be a proper Python API. Okay, thanks so much, Seville. It looks like we have some new folks to the stream, and I suspect that's because of the live banner on Adafruit.com, which is really awesome. So thank you all so much for joining me for my stream. I'm just gonna pull up my. Actually, maybe I'll put a wrap up time code. 2:15:09. So just putting a time code there. So that's by far the biggest note stock, which is awesome too. So this has been a deep dive with Scott. I do this every Friday, nearly. I think I might take a week off at some point, but Fridays at 2 p.m. Pacific. I work on CircuitPython for Adafruit. So if you want to support me, support Adafruit by going to adafruit.com and helping them out, which is good. They are like huge supporters and creators of open source software and hardware. I'm fortunate enough to work on open source all day, every day, which is amazing because of them. So thanks to them. Fridays, 2 p.m. Pacific, I'm here on Adafruit's streaming stuff. You can go watch my back catalog of all the deep dives. I'm being good about taking time codes now. So in YouTube, you should be able to like skip around to different sections. Alvaro says, please like the video. So go ahead and do that. If you want to chat with me and follow along with CircuitPython development more closely, I highly encourage you go to adafru.it/discord. That is the Adafruit Discord server, and that's where we coordinate CircuitPython development throughout the week, and we answer questions and things like that. So if you want to do that, that's great. Next week's stream is on Friday as planned, I think. Bad Evie, thanks for watching. And Alvaro points out that if you want that grayscale e-ink, there's one left. Or not Alvaro, sorry. DCD pointed out that there's one e-ink left. We'll definitely cover that in some streams at some point, probably. I need to make sure it works with CircuitPython. So expect to see that go by at least. And as always, thank you so much. It's been fun hanging out. I think we hit a peak concurrent viewer here for all of them, which is awesome. I think it's 77 just on YouTube, which is amazing. So welcome to all the new folks. I do this every week. Support Adafruit. They support me. Adafruit.com. And I will see you next week. I will pet the cat and then end the stream. Because, you know, cats. Hi, kitty. Chin scratch? All right. Have a great weekend, everyone.